All right, I'm going to kick us off. So let me introduce myself. My name is Diana Griffin. I use she, her pronouns, and I'm a senior product manager here at Nava. I am thrilled to be here today, joining my colleagues Charlie Chang and Kevin Boyer. We'll be talking today about our work to explore applications of AI to enhance access to public benefit programs. As you're listening to the presentation today, feel free to type your questions into the Zoom Q&A feature, which should be at the bottom of your screen. We will hold some time at the end of the presentation to answer questions that come up there. So you can be dropping them in throughout the presentation, and we'll come back to those at the end. I do want to note that today we're sharing a point in time of this project, and we're still in the midst of working on it. So our goal is for this to be one of many share outs as we make progress on this work. So we'll kick off the session with an overview of the goals of the project and the phase that we're sharing about today. Then we'll do a deep dive into our experimentation to develop proofs of concept for different AI tools that could support people who are navigating the application and enrollment process for public benefit programs. And before we wrap, we'll share what we're working on now and what's coming next. But I do want to start us out by grounding in the scope and the goals of the work. The project is designed to explore opportunities to develop AI-powered tools to assist benefit navigators. These are people who help others apply and enroll for benefits. They have roles like case manager, librarian, social worker, and many others. And in these roles, a common and persistent challenge is the depth of local and specialized benefit knowledge that they rely on. And underneath that, the complex and frequently changing policy landscape, which makes it costly to train new navigators, lengthy to develop expertise in the role, and a real burden to maintain up-to-date knowledge, even after reaching an expert level. Given these challenges, we're excited about the potential for generative AI to make navigators' work a little easier by reducing cognitive and administrative burdens. But our primary goal in this work is to develop insights and capture learnings that contribute to broader conversations about what it means to use AI responsibly to support people's access to critical benefit programs. That said, we don't want to shoehorn in an AI solution where it doesn't make sense or where there are simpler levers for change. Even with the focus on AI applications, or perhaps especially because of that, our approach to shaping and building these tools is rooted in human-centered design and user research. And we're very lucky to have a large network of collaborators on the work. We partnered with Benefits Data Trust to define and test AI concepts. They operate call centers where specialists help people screen and apply for benefit programs. And we've learned a lot from those navigators' experience. We've also formed a strategic advisory council of 8 leaders that are operating at the intersection of human services, advocacy, and technology. And we meet with them monthly to get feedback on our progress. And many of the insights that inform the work you'll hear about today come from the 13 members of our Family Advisory Board and from our ongoing interviews with community-based organizations. Our designers do an amazing job continuously engaging with these groups in the research and design process. And that ensures that what we build is grounded in and responsive to real validated needs. So through engaging with these partners and potential users, we identified opportunities where AI solutions could be impactful. And we shared more detail about that phase of the work in our April demo day. So we'll share a link to that previous demo day recording if anyone wants to catch up on it later. From there, we conducted an experimentation phase where we validated ideas and built proofs of concept across a handful of those opportunity areas. And that's what you'll be hearing about today. We designed our experimentation phase so that we could validate foundational hypotheses about the potential value and feasibility of our concepts for AI tools. We mocked up our ideas of what the solutions could be and validated those with users. And in parallel, we built proofs of concept based on what we could test quickly in low fidelity formats using available data and tools. And as we're demoing these tools today, you'll see we built on top of common frameworks for LLM-based development, things like Chainlit, which allow us to jumpstart our development. So today, we're going to focus on 3 proofs of concept that we built. The first is a tool to provide tailored case notes to explore how AI might help navigators provide guidance to their clients about next steps. Second, a document analyzer that explores how AI might help navigators process documents and ensure that they meet requirements. And the third is an assistive chatbot that explores how AI might help fill the knowledge gaps for navigators. So from here, I'm going to pass it to my colleague Charlie to share how we built out the case notes proof of concept and what we learned from our technical exploration.
Hi, my name is Charlie Chang, and my pronouns are they, them. I'm a software engineer at Nava. We want to take a look at summarizing case notes to improve navigator workflows. By reducing the time and focus taken away from client interactions, there isn't always a one-size-fits-all model. By using case notes, we can create a personalized set of action items for navigators and clients based on benefits discussed. Imagine you're on a service call and you're being transferred to a different department or continuing a call at a later time. You don't want to have to start that call over by repeating personal details that have been previously discussed. Having a personalized log of key discussion points can be helpful for both navigators and clients to pick up where they left off. For our technical approach, we work with navigators to simulate calls and convert call recordings into transcripts. The simulated calls avoided the issue of having to secure PII while still giving us real-world scenarios to test. We tested with navigators who were conducting screenings for single and multiple benefits programs like SNAP and LIHEAP. We noted that multi-benefit calls also pulled a lot more information about clients' living situation and increased the length of the call transcript significantly. Some of the tools we used were Chainlit due to its built-in front-end interface, and a variety of different summarization techniques passed through a template created with subject matter experts. For the stuffing technique, we passed an entire transcript to the LLM for processing a single summary. We used a variation of chunking where the transcript was broken down into sizable chunks. Each of those chunks was processed by the LLM to summarize each of those segments. And the collection of summaries was then passed to the LLM again to create a final summary of those processed chunks. For refinement, we also broke down the transcript into segments, but instead of summarizing each chunk separately, we would summarize the segments iteratively as we read the transcript, creating a chain of summaries based on previous segments. We also tested using open source tools for the potential of reducing costs and increasing privacy in proprietary LLMs due to their efficiency. For our prototype, we built a chatbot to make it easy to test LLMs and different summarization techniques. We begin by selecting an LLM, our summarization technique, and then uploading a transcript. You'll notice this process is pretty fast given that the LLM only needs to process the transcript once. So here we have information extracted from the caller, the reason and type of call, previous benefits history, and some discussion points, in addition to documents needed and next steps for the client and the agent. You'll notice that one of the discussion points mentions that the client is interested in Medicaid due to dental issues. Keep this bullet in mind as we're going through the next summarization technique. So while we're selecting a new summarization technique, re-uploading transcript. And here you can see the process takes a bit longer, and this is due to the LLM processing multiple chunks at a time and generating multiple summaries. We can fast forward a bit. And when we compare the results, you'll see that parts of the caller information is missing from the chunk summaries. However, if you scroll down a bit, you'll notice that the discussion points are a little more organized and concise, omitting that extraneous information like the interest in Medicaid due to wanting to visit a dentist that we saw in the stuffing example. So we would use stuffing in cases where we wanted a more detailed description and chunking in cases where we need to consider brevity and conciseness. So what did we take away from this? We realized that prompt engineering was super important as we worked with subject matter experts and the staff at BUT to get a better idea of what information is key for our summary templates. We found out that if we didn't specify which details were important, the LLM would decide that information for us. Stuffing worked the best in our tests since we were using shorter transcripts. However, we found more concise discussion points through the chunking and refinement process. The exact details are missing, such as the contact information and some referral details. We weren't too concerned about this since it's captured during the screening process. So the time to summarize the transcript was roughly 3 to 4 minutes for proprietary LLMs, over 20 minutes for open source LLMs. We also found less hallucinations for proprietary LLMs, and by hallucinations, I mean incorrect information generated by the AI. So in short, we need to be mindful of LLM limitations. We use open source LLMs for configuration and testing, but proprietary LLMs perform faster with less hallucinations. We can also think of the summarization technique like a game of telephone. As information gets distilled or changed along the way, the more we iterate through the information, the muddier the summary can become. In a well-done summarization, the final summary should accurately reflect the main points of the original transcript, but in a much more concise form. Now I'll pass it over to Kevin, who will discuss our other prototyping experiments.
Thanks, Charlie. Hi, I'm Kevin Boyer, pronouns he, him. I'm a software engineer on the Nava Labs team here at Nava. And I'm going to walk through our next 2 proofs of concept with you all, starting with our document processing experiment and then our assistive chatbot experiment. So as folks know, clients of benefit programs often have to provide lots of documentation as part of their applications, as well as during their ongoing participation in the program. One example of that is SNAP in South Carolina, where participants need to provide things like evidence of their identity, their residence, income and expenses, and other attributes of their application. And South Carolina is an especially interesting case for the team because there isn't an explicit list of exactly what kind of documents do or do not constitute evidence of things like your identity. There's room for reasonable human interpretation. So for example, if you are a student, your student ID might be acceptable. We wanted to understand if multimodal LLMs, so models that are able to process and understand and extract information from images as well as text, might be able to interpret uploaded documents, assign them to various evidence categories, and even extract important information for a caseworker out of them. So for example, could an LLM automatically recognize that a copy of someone's lease constituted proof of their residence, and then also extract their address from it? And that in turn might let us build a tool that could quickly flag for applicants ahead of time if they'd forgotten to upload a piece of documentation, or if any of the documentation they had uploaded seemed to be inappropriate or out of date or unreadable and needed to be fixed. And that in turn could help to reduce burden on caseworkers and ultimately help clients get assistance faster. So here's what this experiment looks like. I'm going to upload multiple files here, and while they're getting processed in the background, I'll kind of walk through what I've just uploaded. So in the background, these are being processed by, in this case, OpenAI's GPT-4o model. And I've uploaded a driver's license here. Let me see if I can zoom that in for you all. There you go. These are, of course, all synthetic. This isn't even real data. Here's the same driver's license, but blurry, as if it were taken out of focus. And we've got a variety of other documents too. So for example, a leasing agreement, a copy of someone's tax return, and a South Carolina voter registration card. And these typically take, we render these into one image per page, so a multi-page document becomes multiple images, and they typically take between 10 and 15 seconds. And of course, we would be remiss if we didn't have the demo day with something happen a little strange. Let me try that one more time. Wonder if I accidentally added another file. No, this all seems correct. And what we'll see when it finishes processing is that it is going to first attempt to view these documents and see if they're actually readable. So one of the early things we found was that the LLMs could actually work with quite poor quality uploads that a human probably would not find acceptable. So we had to do some prompt engineering to say, no, like you should very strictly evaluate these and not be afraid to reject them as not readable, even if you can successfully run OCR and extract text from them, but instead require that a human also be able to understand them. After that, it's going to try to map on its own each document to the particular type of document. So not just is this proof of ID, but is it a driver's license? Is it a student ID? And so on. And then finally, it's going to try to extract useful information out of that. And almost none of this is going to be hard-coded in. The actual prompt that the LLM is receiving is quite generic and instead just provides general guidance about the broad evidence categories that we'd like it to assign these documents to. All right, we should get results any second now. All right. So first, right off the bat, the blurry driver's license is not legible. So this is something we could flag for a navigator, for a client, that, hey, they might need to retake this photo. We can also see it generally is pretty on the nose with the document type. So it calls this a residential lease agreement, this a tax return, this a voter registration card. Again, none of this is stuff that we've pre-programmed in. It's just trying to broadly categorize each of these documents. Then below, it's now mapping these documents to what kind of evidence. So the driver's license is proof of your residency if your current address is what's on the driver's license. And we can already see a little preview here that it's extracting the address. It's also proof of your identity. Similarly, your leasing agreement can be used as proof of your residency, and your tax return might be something you could use for proof of your income. We also asked the LLM to just tell us yes or no. Does this particular document contain a photo of the person? So driver's license, yes. Leasing agreement, no. One of the things we found is that trying to program complex multi-part rules into the prompt, so saying this document needs to not just provide identifying information, like for example, a social security number on a tax return, but also needs to contain a photo before it's called proof of identity. That led to some false positives where the LLM was saying like, well, it seems like it's reasonably proof of identity, even though we had explicitly told it not to count that unless it contained a photo. On the other hand, we did find it's just pretty accurate being asked directly, does this contain a photo or not? And then on our end, we can use very standard programming to just say, okay, the LLM has to think it's proof of identity, and also it has to say that it has a photo before we're gonna let that accept that evidence category for this document. Then I'll also show, we asked the LLM to extract arbitrary information from these documents. So here we can see on the driver's license, it's pulled things like the driver's license number, the date of birth, when it was issued, and so on. Again, none of this is anything we've hard-coded in. We've essentially tried to ask it to just extract what it thinks is the most important information and then label that information in a human readable way. One final thing I'll show, and then we'll again look at the timing and the costs here. If you were an eagle-eyed watcher, you may have caught that one of the documents has a kind of a funny address that the LLM extracted here, which is 1600 Pennsylvania Avenue. But I kind of purposely didn't show this ahead of time because I didn't want to spoil the fun here. So this is being called proof of evidence that this person lives at 1600 Pennsylvania Avenue. Here's the actual document that I've uploaded here. Okay, so obviously, right, I just tore up a piece of notebook paper and told the LLM it's a photo ID. It is kind of interesting that it's capable of understanding handwritten text, not just typed text. I don't think I have the best handwriting. On the other hand, this does kind of show a key caveat for this, which is that it is a tool for empowering clients to understand whether their applications are complete or missing any kind of information. It absolutely cannot be a substitute for human review or replace humans reviewing applications to actually make decisions about them. So it's a tool for helping people understand if they themselves have their documentation ready. And then scrolling down here, the time here can vary. We've noticed that sometimes you'll occasionally see an exception where like one image takes much longer to process than typical, but usually it's about 5 to 15 seconds per page. And the cost is pretty consistently about just over 1 cent per page to process. I'll also say too, we didn't spend a whole lot of time optimizing this. There are a couple kind of low-hanging fruit techniques we could do, largely around just shrinking the images or compressing them to further improve the processing time and the cost here. So we think this has a lot of promise using multimodal LLMs for document categorization. Again, with the significant caveat that this is a tool for helping clients understand the state of their own applications and catch errors, and not as something that can be used as a substitute or to like automatically adjudicate applications. And finally, while LLMs do have some limitations, particularly around complex reasoning, so saying like not just this includes identifying information, but also includes a photo, using an LLM in this way isn't exclusive with standard programming techniques. And in fact, combining the two methods results in a more effective product or service than using either in isolation. All right, the next experiment that I'm going to be sharing with you today is our assistive chatbot. So as Diana mentioned earlier, we know that navigators often have to help clients through complex and unique circumstances that the navigators may not have encountered before or understand how to interpret in the particular context, how to interpret the policy in this particular context. And in these situations, navigators often have to reach out themselves to other colleagues or resources that can help them understand in turn how to advise their clients. And all of that takes time. And in general, the complexity of policy also means that it takes longer and training costs are higher. So we hypothesized that we could build a tool to specifically try to answer navigators' questions directly without them having to then independently go search or tap a colleague on the shoulder. And that we could do that by using RAG, or retrieval augmented generation, to provide an LLM with the specific information it would need to answer the navigator's policy question. So in other words, when we get a query, we retrieve the relevant policy and then augment the generated response with that policy information. For this experiment, we leveraged Guru, which is an internal policy knowledge base used by our navigators, used by navigators at our partners at Benefits Data Trust. And Guru is structured a bit like a series of frequently asked questions. So it's a series of questions like, can college students apply for SNAP? And then a vetted answer to that question. We digested Guru into a database that we then use semantic search on to identify which Guru cards are most likely to be relevant to answering the navigator's question. We then summarize those findings, share that with the navigator, and also provide the Guru cards directly. And here's what that prototype looks like. So not much to start. We start with an empty chat interface, then we can ask questions down here. Let's see, my client is a part-time student, but also works. Are they eligible for any food assistance programs? And in the background, we're searching Guru, finding the relevant cards, and then trying to summarize those and use those to produce a top-line summary or answer to the navigator's question here. All right, so here's our answer. A couple other features I'll call out. One is that we are intentionally surfacing all of the cards that we found to the navigator so that they can see these directly. And that includes showing the text itself. So our first Google card here is actually pretty relevant to this question. Someone can then click in. This text isn't being generated by the LLM or by us. It's directly surfacing the text from the Guru card itself. And that helps folks be able to either quickly validate the answer that they've gotten, or if we didn't answer it well, or they just want to dig into the primary sources themselves, they can start to do that. I'll also call out, you can see here the LLM, often our semantic search finds Guru cards that aren't particularly relevant. For example, this question around, are live-in attendants included in food stamp households? That's okay, the LLM is able to kind of ignore irrelevant information in this context. So let's ask one more question, and hopefully that'll kind of show why we found it so helpful to not just provide an LLM generated answer, but also surface the Guru cards themselves. So I'm gonna ask, my client is a college student enrolled full-time. Can they be eligible for SNAP? And the fun of demoing, I've gotten mixed results with this question before. Here we can see, we get this kind of an interesting answer, which is yes, if they meet certain conditions. And we can start to see a list here. And in fact, if we click in, so this second Guru card can seem to be part of the SNAP household. We'll see where the LLM is pulling this list from. And one of the bullet points here, we didn't stress too much about formatting the actual original text for this prototype. But one of the bullets here that got left out was still in high school. So in fact, the LLM has missed this kind of crucial qualification, right? That this is a question about college students and has started pulling from something that is more focused on students that are in high school. The final feature that we've built in so far is the ability to provide feedback when we run into things like this. So at the bottom, there's this chain that provides us this infrastructure for being able to quickly mark things as helpful or not helpful, and also provide feedback. I asked about college students, got an answer about high school students. And then they can submit that, and that goes back to the development team that can then start to investigate where things may have gone wrong and start to improve the service from there. And on that note, evaluation is critical, and one of our early findings is that having a very large, robust set of pre-vetted question and answers for a tool like this that you can use to evaluate the performance of the tool is critical. And that goes beyond understanding, is this the right answer? Being able to assess the overall accuracy is important because it helps us understand whether the underlying architectural changes that we're making are actually improving the performance and usefulness of the tool or not. So it's not so much about being able to run a large series of questions through the tool and get something back where we can definitively say this tool is accurate 65% of the time, but it's about being able to see when we made this change or added this new data source, accuracy increased by 5%, or maybe it fell by 5%. And then finally, 2 early service design takeaways. One is it's important to show direct quotes that the user can trust come verbatim from primary sources, because it helps users more quickly assess whether the overall answer they're receiving is accurate or not. And that references to source material also empowers users to, beyond just validating answers themselves, maybe even just skip the AI generated summary entirely and start digging into the documentation faster. So we also think this experiment is particularly promising. We're continuing to iterate on this tool. In particular, we plan to build additional intake pipelines for other sources of data. So for example, the Michigan Multi-Benefit Handbook. And by doing so, we'll also test out our ability to expand the scope of the chatbot beyond SNAP into multiple benefit programs at once. And finally, and excitingly, we're testing this product with real navigators and using the insights we've gained from them to further iterate on and improve the design and user experience of the tool. So thanks for listening to me. I will pass it back to my colleague, Diana.
Thank you so much, Kevin. So as we've just seen, testing the proofs of concept, oh, there's the slide. Testing the proofs of concept that we just shared did validate that each of these tools does show promise in supporting navigators in their work to help people access benefits. So we're currently focused on taking it a step further to refine the tools into more robust prototypes and test how they help navigators in their real workflows. So going from proof of concept to prototype and really thinking about how this fits into a navigator's work. We are currently speaking with potential partners to design a pilot of one or more of these tools in their organization setting. And through piloting, we hope to evaluate our hypotheses further. So we'd be asking questions like, do these tools actually reduce burdens for navigators and make their jobs easier? Do they provide information that navigators didn't know or couldn't easily find or produce otherwise? And ultimately, does supporting people via these tools actually lead to better outcomes in terms of accessing benefits? We are very excited about this next phase of work, and we are so excited to share more about prototype development in our next demo day, which we hope you will be able to attend. In the meantime, you can visit our website to see information about the user research that informed our work, a case study describing the experiments we covered today, and we'll continue posting about our ongoing efforts to pilot these tools. So that's it for us for now. We've really appreciated getting the chance to share what we're up to with you all. We do have some time to answer questions, so please add your questions to the Zoom Q&A feature. And I have seen some questions coming in already, so we'll jump in and start answering those. Let's see. First up, we did have a question about the case notes proof of concept. Someone asked, I'm curious to learn more about how you created simulated call sessions and determined what good results look like. Was there automation in comparing the results? That is an excellent question. So first part of the question, how we created the simulated call sessions. This is where our partnership with Benefits Data Trust was one of the many ways it was so very valuable. But we had the opportunity to actually in a couple of different ways. One, we sat down as part of our own discovery effort, sat down with some of their subject matter experts, navigators, and call center specialists who actually demonstrated for us what a typical call or series of calls might look like. And we were able to record that as a simulated call session. We also were able to benefit from recordings of simulated calls that are used for training navigators in that context. So these were synthetic calls that we were transcribing just via a Zoom recording like this. I will say that in the future, if we were developing this further, some things that we want to explore would be both thinking operationally with a potential pilot partner around their existing practices or operations for recording calls or potentially transcribing calls, and based on how that is working currently for a partner, we'd be looking at whether there may be some upstream need to work on going from audio of a live interaction to a transcript to the tool, or potentially bypassing the transcript and seeing how a tool does with audio data instead of text. And I do want to open it up to Charlie or anyone else on the team. Is there anything you'd add about that? Oh, that was just about the simulated call questions. Second piece there was determined what good results look like. So that again, we were able to work directly with those navigators at BDT who were able to validate both that template for the types of information that are important for their operations. So what types of information would they want a call summary to capture? And then specifically for the simulated calls that we had recorded and transcribed, actually had them validate of those transcribed calls, what would the sort of right answer for those different templated categories look like? So that clearly is not a process that would scale, which comes to your question about was there automation in comparing the results. For this proof of concept, we were manually reviewing the results, but figuring out how to automate that comparison would be a next step for this prototype. So let me stop talking there and see if Charlie or Kevin have anything to add to that.
I'll just add generally that automated evaluation has proven to be really hard. I think partly because this is such a new space and the ecosystem of different tooling and frameworks is evolving so rapidly as folks kind of figure out what works well and what doesn't. Um, there isn't any silver bullet out there that makes this easy to do. In a different context, I don't believe we did this for the transcript summarizer. I believe we did this for the assistive chatbot prototype. We did run a very early experiment where we used LLMs to then evaluate other LLMs. And some of the very sort of nascent findings from that were one, it quickly becomes very expensive to do at scale in a way that when you have a few kind of calls running out to a proprietary LLM to do inference and generate a response, when you're trying to do that across many different thousands of Q&A and like run that multiple times at different settings, quickly becomes very, very expensive. Or at least expensive enough to make you want to think very carefully about running the automated evaluation. The second and maybe more surprising one was that it still doesn't eliminate the need for human review. So even having an automated LLM grader that tries to say like, all right, here's a question, here's what I know the answer should be, and then here's the answer that the tool produced. Do these two answers match? If so, the tool got the right answer. If they don't match, it got the wrong answer. When I say that out loud, it seems like that should be a pretty objective finding. Do they match, yes or no? In practice, what actually happens is that both the ground truth answer generated by a human has some element of creativity to it, and so does the generated answer by the tool. So if you get a straightforward seeming question, are college students eligible to SNAP? The answer to that, even from a human, tends not to be just an up or down, yes or no. It often involves like asking follow-up questions to better understand their circumstances. And so you get these ground truth answers that are in the form of like, yes, if, or no, but, da, 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 da. And it becomes pretty difficult to try to like just objectively match that kind of contextualized answer or response automatically with the generated tool. So we had this kind of like stacked layer of like an automated LLM trying to like compare answers and like give us overall directional feedback on whether the tool was getting better or not. And then we also, on top of that, had this layer of then humans kind of like coming in and reading the generated answers and comparing them and saying like, well, does that make sense? Would a human agree that the tool got the correct answer here? Or would a human say like, no, it like mostly got there, but then it, you know, made a reference to high school students that has nothing to do with the original question. Yeah, great question. I'm very excited about automated evaluation, and I think as a whole, I'm very optimistic that the field will get kind of smarter and more mature about it as it grows.
Absolutely. And I just anticipate that that will be a topic we'd like to cover in our next demo day. We should have some experience with it under our belts by then. There is a question about the document analyzer, asking what models would you use for these if you were processing real documents? Would you remove PII and then run through cloud-based models or process the full document locally? Kevin, can I ask you to address that one?
Yeah, it's a really good question. These were synthetic documents, so we sent these over the wire to, in this particular case, OpenAI's API. For real documents, as you know, like PII quickly becomes a concern. So you have to understand, one, are you comfortable with that? And the answer to that may very well be no. And then in that case, you have a couple of options. One is these large providers are starting to offer ways to run inference against their models that run just within a different cloud provider. So for example, Anthropic's models, I believe, are available by an API called Bedrock, which is a part of AWS. And in that case, your data is sort of staying within the AWS cloud, which you may, or you know, that may be acceptable to you to keep PI within that environment. Don't quote me on that. I don't work for AWS or for Anthropic. But that seems to be where the field is trending for these concerns around like, hey, we're comfortable with the security agreement we have with GCP, Google Cloud, or with Microsoft Azure or Amazon AWS. We're not necessarily with these third-party companies, so we're comfortable with PII as long as it's sort of staying within that contained fence. The second option, particularly not necessarily for the document processing model, but for some of these others, is about finding a way to run these models locally. So for our own, the engineers on this team, we've actually had pretty good success with using tooling like OpenHermes to then download models like Llama 7B or Llama 2.7B, and then run inference totally just directly on our laptops. We're of course doing that as developers, so we're not really using PII in that context either. But if we were, it wouldn't be leaving our laptop or our machine at all. So there'd be no concern about that data going, whether encrypted or otherwise, to some third-party server. For the document processing model specifically, that prototype is using multimodal LLMs. I'm not personally aware of any multimodal LLMs where that's an option to run things locally. That's just my own lack of familiarity with that. It's very well possible there are. The major ones I'm aware of are Google Gemini and then OpenAI's GPT-4o.
Great, thanks, Kevin. Looking through, I'm seeing a handful of questions related to the knowledge base content. So for this proof of concept, that was the guru content. Folks are asking who would be responsible for making sure Guru is up to date? Where are you getting the qualification criteria for the benefit programs? And do you do any testing with organizations to build on the knowledge base created so far? So I'm going to answer those together. In this context where we've been partnering with Benefits Data Trust through this experimentation phase, the Guru knowledge base is their internal knowledge base for their organization and for their call center operations. So that was an existing knowledge base that we have leveraged as the data source for this proof of concept. So they already have processes and operations in place for keeping it up to date. They have a policy team that reviews the benefit program policies and regulations and all of the relevant information and make sure that that is reflected for the folks who are supporting their clients. So we have really benefited from a lot of work that was already in place operationally at BDT. And we were able to work directly with them to understand kind of the shape of that content as a whole and how to leverage it for this tool. I know someone, I think, asked in the chat, what is the format? And that what you saw in the chatbot is really directly the format of those Guru articles, where it's, as BDT has structured it, it is a question and answer format where the title is a question and the content is a sort of paragraph answer to that question. As Kevin mentioned, we are really interested in experimenting next with what it looks like to apply different data sources or kind of bring different data sources into the chatbot. So moving from this kind of customized proprietary knowledge-based content, organization-specific, to looking at feeding in publicly available policy information or benefits information from different sources, whether that's working directly from benefits manuals or from benefits websites, looking at what it looks like to kind of swap in different data sources and see how the tool performs when we make that type of change, looking at information in different formats, for example. So we'll be excited to share how that goes in future demos. I do want to keep an eye on the time. There are lots of great questions in here. Also related to the chatbot, although it's probably a relevant question for any of these tools, would benefits navigators need to have multiple screens open at once? Or could the chatbot or any of these tools be embedded into the tools they're already using? We're not that far in development to have a perfect answer to that question, but certainly the idea is that what we're building could be implemented into or integrated into an existing tool. essentially the code that we've written so far is open source, with the idea that folks can take a look and kind of see what it looks like to try it themselves. And we do hope when we move into a piloting phase, we'll be looking at that question with partner organizations. So what would make sense in terms of making the tool available in a navigator's workflow, and collaborating with partners on kind of balancing integration with keeping it lightweight for a pilot. But certainly at its foundation, it is something that could be implemented into another system, but is not yet in the form of like a plugin or something that just kind of like can be easily configured into a commercial tool. Let's see, maybe that leads us into some of the questions that are a bit more general about the project and about looking for pilot partners. So just to answer some of the general questions, someone was just confirming, are any of these experiments live? As of yet, these are still proofs of concept just being tested, but we will be, again, planning to test them live in a pilot phase. So looking to develop the prototypes over the next few months and move into piloting quite quickly, as soon as we can. And let's see, someone had asked about the size and the makeup of the team. I can just answer that quickly and use the opportunity to shout out my teammates. So in addition to myself as the product manager, Kevin and Charlie as engineers, you may have seen participation in the chat from Yoon Lam, our tech lead, and we do have 2 designers on the team as well. And we also have a partnerships and evaluation lead. So that is 8 people on the development team, which really, I think, speaks to 2 things. One is how grateful we are for all of the collaborators and partners that I mentioned at the top, as well as really highlighting that there's a lot that can be done with a small team, certainly at this experimental phase, in order to just try things out and start to learn you know, things about feasibility and value that can be done quite quickly. And let me just take a look here. Checking if I've answered questions in the chat. A couple of questions around, I think I'm going to combine these 2 questions. One is, where and to whom would you imagine this tool would be put into immediate use or show most benefits? And then another question, what are your criteria for determining which partners or navigators you might work with, including call centers? So the validation that we've done through this proof of concept phase, as I mentioned earlier, like we have validated that there's potential value here. And really the next step is to have conversations with organizations that are interested in these tools. We are very interested in just talking about possibilities because there's a lot of flexibility at this stage where we can think through together with a partner what needs to happen and what a pilot would look like with them. So I don't want to kind of narrow the field prematurely by specifying particular criteria other than, as the question itself mentioned, we do want to work with organizations that have navigators, that have some existing operations around supporting clients who are accessing benefits. And the specific mechanics of how they do that are things that we can talk about with organizations. So certainly if you or any organizations that seem like they would be a good fit for piloting this with us, we would love to hear from you and have that conversation. And I think, just checking here, we may have answered all of the questions. Someone asked, what is the timeline you anticipate for building out these tools to apply to other state programs other than SNAP? That's something that we are currently working on. So at least at the kind of experimental proof of concept level of just looking at using different data sources for the chatbot tool, the actual act of applying a different data source is relatively quick. It's really the evaluation of how is that performing and the refinement of that tool in a more specific context that is a little more variable. So that's sort of the work we're doing now. And I would anticipate that the next time we share out on this work, we'll be able to speak to that. All right. Oh, a couple more questions coming in. As you move from prototype to live pilot, do you have thoughts about how you might evaluate these solutions against non-AI solutions? For example, asking the AI chatbot for guidance versus searching and using Guru's existing interface. That is such a wonderful question. We really feel strongly that if a non-AI solution exists and works, you should really consider whether you need AI. So for this example, it's a great one that you brought up. Is asking the chatbot to retrieve Guru information actually better than searching using Guru's existing interface? That was something that we validated early on with the navigators at BDT, and they, I think, pretty strongly and consistently indicated that yes, they would prefer a more direct conversational way of retrieving that information, and had at least encountered some complexity, or at least some time that goes into using the Guru search interface. But that is an excellent question, and really we strongly recommend that that should be part of any assessment of an AI tool. Is this actually better than a non-AI solution? All right, I think we are wrapping up here. So for anyone who is interested in further conversations with us, I will go ahead and drop my email in the chat, and we would love to hear from you and take the conversation further. Thank you so much for joining us today. We hope that this has been interesting and that we can share more next time.